data. So where we basically use graph, charts, tables, and aggregations, calculations, percentiles, all these things goes there. And inferential statistics is like estimations. Estimations means what can happen in the future based on the previous operations. Okay. um, so for example, in this you can have some topics like hypothesis testing, so which is like one of the important thing in business industry. So these are like an important interview questions to people used to ask what is hypothesis testing. Okay, and we'll check on it later. And both are like basically interlinked. Okay, so one is without not other. Okay, you may necessary to use descriptive stat. For example, you already have tons of data in your database. You just need to perform some analysis on it, like what went wrong in my business. You to statistics. Okay, for example, boss asked you to find what would be the sale based on the previous data, all the data you have. Then you go with inferential statistics. Okay, so that how we have to use. It's not like you can use only one. It depends on it, the use case, like where you will use what. And when it comes to statistics, these two terms are like a bit important actually. Okay, so one is population and another one is sample. Do anyone know what is population and sample? Do you guys know what is population and sample?
No, sir.
Oh, okay. Okay. For example, uh, we are doing a market study. Okay. Okay. We are doing a market study in India. Okay. So in India, we just split it into certain boundaries, one, two, three, four. So maybe north, east, west, south. Okay. Assume these are my boundaries. So here I have this. I have many people inside it. Okay. So assume these dots are like peoples. So we cannot. There may be many peoples, right? So all this, all this people are called as populations. Okay, so these all called as population. So population is the entire group of data which is in my case study. Okay, so if you considered every point in the data or entire data in my study, so that is considered as a population. If you take a certain, so you don't need to take all the people data. So you just need to diversify the data by selecting few samples. So if you take certain things out of the data, so where it is called as sample. So this is population. So this is basically population. So sample lies here. So why the reason we need population and sample is like you cannot have all the people informations collected and stored it somewhere. That is impossible to do it. Instead of that, to represent a bigger population, we take a certain amount of small amount of data. So that is called a sample. Okay. So population is a collection of all individual or items under consideration in a statistical study. So sample is a part of population from which information is collected. So you take all the people in the study. For example, you are performing. So assume you're performing an analysis on a school. Okay, which is from grade 1 to 10. So if you analysis how many people are in like having average marks. Okay, so for example, if you perform an analysis with respect to only seventh grade, you can collect those data all like in seventh grade. Assume there are 50 members. You take all the 50 members and perform some statistical study. So assume that is a population. For example, assume you have to do for 1 to 10 grade. Okay. Instead of that, what we will do, we will select some random people from each grades and perform some study on it. Okay. So that's a sample study. So which like all this people, the for each class we took only 10 people. So that 10 people should represent that 50 people. Okay. So a population actually always represent the target of an investigation. We learned about like population is like your samples should represent the population. Okay. So what is the right way to select a sample? So where the design of experiment comes actually. So there are certain techniques which we will use to select right samples. Okay, we'll see it in the further class. And so parameters are like used to like basically used to summarize the features of populations under the investigations, like what is the mean, median, average, so all those things. So under statistics, like what is the characteristics of the samples. So parameters are basically with respect to the population, but statistics are basically like it describes the characteristics of the sample. I will explain it further also. When unknown parameters comes also, we would able to make some inference on it. Whenever I use the inference term, assume it's like you are predicting something. Okay, so which I already explained. You can either call it as inference or inferential statistics or descriptive or descriptions, all lays in the same line. Okay. All right. Yeah. Anyone have doubts of sample and population? So that is bit important here.
No, sir, no doubt.
Thank you. Okay. Uh, so when you so we have like types of data. So basically, how many types of data we have? Not with respect to programming, int, float, long int, not like that. I'm generally asking how many data are there if you segregate in the real world. How many kinds of data are there? You can take any data. So basically, how many data we have? So what are the types of
Uh,
data?
Sir, ordered or unordered data, I think.
Ordered or unordered? I'm asking in like assume a layman term, like someone who don't know like ordered or unordered. So when you use Instagram, so what are the data mostly there? Image data, right? So I'm asking in that sort of way.
Structured, unstructured.
Structured, unstructured. So structured are like datas with our like assume like if you have a data which is in a tabular way, then it is called as a structured data. Unstructured means like you cannot arrange the data into certain ways. Okay, so that is called as unstructured way. So in structured way, we have two datas. What are those? In a table, we can store two kinds of data. What are those?
Discrete and continuous.
Other. Oh, what is discrete? What is continuous?
Continuous data means, sir, like data from 1 to 2. There are many points, 1 to 1.3, these types. And
Okay.
discrete. The discrete are fixed and defined, sir.
Discrete are?
Like fixed and defined.
Okay. Okay. So
Streaming data,
what data? I didn't get it.
live streaming data.
Okay.
For example, we are extracting some sensors data, right?
Ah,
So it's basically live streaming data. Is whatever the input they are getting, they are transmitting the data to system.
okay. Okay. Those are temporal data basically. Okay. So temporal data is nothing but when a data which basically change with respect to time. He told sensor data, right? So when a data which changes with respect to time, so that is called as temporal data. Okay, so first thing is like so we call this as a futures, okay, in data analysis. So when you have a data, so the data can be segregated into multiple things, okay. So in that way, so we usually call that as a future, okay. We don't call that as a data type, okay. In case if you are in programming language, so that is called as a data type, but in analytics side, that is called as a future, okay. So a future can be classified into many types, okay. So but basic things are like it will be like if you take a future, so future is mainly classified into two cases. So one is like categorical data and numerical data. So categorical and another one is numerical. So categorical means if you take something and assume like it is a fixed value, usually a fixed value. So fixed value means if you take something like for example gender. So if you take a gender, it can be like a certain set of formulations. Okay, inside that only it can fall. So if you take a maybe a blood group, so it can fall under a certain set. Okay, so if you have something like can take one of the limited values. Okay, which is usually fixed, okay, and which can be like you can statistically if you want to call, like you will have set of possible values somewhere which will be written from something you can select a one out of it, okay. So that is called as categorical data. So assume like all our text fields, like if you select some male or female or your city or your gender, or these things comes under categorical. So in case when numerical means like if you have something variable in a data within finite to infinite intervals, okay, which can be in finite or an infinite interval. So which is basically means numbers, okay. For this, if you want to take an example, like height in centimeters, then weight in kg, all these things are like maybe if you have some data like number of movies watched, okay, number of movies. So all these things are considered as a numbers, right? So basically, when something denotes as numbers, then that is called as numerical. So even categorical can be split into other two also. So we called something called as nominal data. um, Nominal, and we have something called as ordinal. See, these are for theory only. You may not use all this. For us, it will be like number or text in the real world. Okay, but so our theories, I will cover it. So if you have something like which does not have a certain specific order, okay, so where there is no order. For example, if you have gender, right, so there will not be no order. Like it can be gender, male or female, certain things, okay. Then it is considered as nominal. So if there is an order in the data, okay, then it comes in the range of either basically if you order something, so then it goes to the nominal data. Okay, so data is like example male or female like this. Meaningful ordered means like it is like ordered. For example, if you take rank, so rank can be 1, 2, 3 only, right? So if you take some order into consideration, so nominal and ordinal goes there. Okay. Then inside this, similarly, we have in numerical way, we have something called discrete and continuous. We already talked about it. So here we have, so this will comes under discrete and continuous. Discrete, then continuous. So in case of continuous, for example, it cannot be ordered. So like there will not be count long time count, but somehow you can count it. For example, you can even count any numbers can be counted. Okay. For example, if you have world population or something which can be increased further also, like right. Uh, or if you found count someone age or certain things where it goes to the continuous. So basically continuous variable can take like any numerical value which are like uncountable. It could take forever to count. Okay. Like basically if something in like this R goes as a continuous, discrete values can basically takes numerical value, but R you can able to count it in a finite amount of times. Okay. So you can think it is countable or not. Okay. So we have some other data also. We have interval data, ratio data. So all these things I will cover. So to understand in base, you just have these two things. Okay. Okay. So we have when it goes to variables or features, you can either mostly call it as feature. So where you will represent some data. So data can be qualitative data or quantitative data. So qualitative means, so this term is bit statistically, if we say qualitative means which are non-numbers. Quantitative means like which are numerical data, quantity. Okay. Qualitative means which is a text data, basically non-numerical data. Okay, then we have discrete data which has a countable number of discrete possibilities. Okay, you can count that with your with the data and put some like a round figure out of it, like number of children's car accidents happened. Continuous data means like which will the variable has divisible unit, like if you take temperature, it moves at a point the value of pi. So independent variable means so anyone knows what is independent and dependent variable? Do anyone have idea about this?
No, sir.
Uh, okay. So when it comes to datas, right, we have something called as independent data and dependent data. So when a data depends on other value, so that is called as uh, dependent variable. If a data not depend on something, then it is called as independent variable. So when we work with machine learning or statistical modeling, so we need to understand like what is independent, what is dependent. Okay. So which are your input, which does not dependent on it. So it may be a bit confusing now. So I will explain on the regression modeling stage what is dependent and independent variable. So assume like you will have some x value and y value, which are like y is basically depends on x. So it usually works on predicting. Okay, you will use some values to predict the inference where like dependent variable basically depends on the independent variable. Okay, but independent variable does not depend on any variables. Okay, so when modeling I will rephrase this. Okay, just ignore it if you didn't understand. So nominal ordinal we already saw actually. So basically they do not have natural of order is nominal. So ordinal means the name has it. If you put something into an order, so like first rank, second rank, third rank, the fever, mild, moderate, severe, or the rainfall, or the temperature, high, low, something you may be able to order it. That is ordinal, name says. Nominal means like those are names only. Nominal, the norm means it's like merely names actually. So that is nominal. And interval scale means like, for example, which will not basically have an absolute zero. Okay, that's it. So the when you cannot say a temperature in zero, there will be some limit. You cannot say a time in zero. That is a certain limits. When it goes to ratio, you measure something like the variable has absolute zero. If you measure starting scale of the weight machine will be zero. So if you measure something which has an absolute zero with it, it is called ratio scale. So there is no zero with it as okay, absolute zero is not possible in that case. Then it is interval scale. And yeah, the nominal and the ordinal scales are used to describe qualitative data, and interval and ratio scales are used to describe the quantitative data. This we already see. Any doubts until here? So you guys are clear like what is qualitative and quantitative means? Any doubts?
No, sir.
Okay. So this is like bit important. Please note it down if necessary. See, in case of qualitative data, it is basically a categorical data, right? We already saw. So which is basically denotes a descriptive information, okay? So which cannot be measured in a certain state, okay? Which are non-numerical in nature. For this data, to perform any kind of chart, if you want to convert a qualitative data into a chart, okay, so we have to use pie chart and bar chart, okay. So the possibility of doing is like, for example, I will tell one example use case. So let's say you have a table which says as animal. So you have cat, cat, then dog, then dog. So you want to convert this into a chart, okay? So how we can do is like the first step is like the frequency plot. So how to derive a, frequency rule is like you have to count the number of elements in each, okay? This is how pie chart basically works in background. So in dog there are two. Okay, so you have to get this frequency count. So once you get the frequency count, then what we will do, we usually plot some plots which can help on plotting it. For example, if you sorry for my diagram. So you can plot cat and dog here in a pie chart. Okay. If you want to do a bar chart, you can plot similarly a bar chart like cat and dog, which are in similar nature. So this how you can convert a qualitative